now is we know all the basic types. Okay, integers is fine, Boolean values would be fine. We have used these specific types already. Are there other types that we can use or even define by ourselves? Let's think about a date. Okay, how do you represent a date or a time? Well, that's good. But what is the most intuitive way for people to represent a date? We have year, month, and day, right? Okay. So that means we want to be able to somehow represent 2010 as the year, and today is November 22nd. Okay. But most programming languages do not have a built-in type to represent a date. Okay, so what can we do? Well, there are some.
Don't they count a number from basically a start point?
Yep, they do.
700 minutes past this start point.
Yep, that's called the. That's a name for that. I cannot remember the name. Epochs. Yeah, the epoch time, EPOCH, time. In Linux, it is it's since 1970 January 1st midnight. And then in DOS or in Windows, it is 1980, since 1980, January 1st, midnight. And it's always using UTC, the Universal Time. What is the C? UTC stands for Universal Time.
Counter. Count something. Universal time clock?
No, it's not a clock. They used to call it just Greenwich time, but now they changed it to something else. Current time in UTC. Greenwich Mean Time was basically the same thing. But it's not here. Coordinated, and it's French, so that's why it is UTC and not CUT. It is Coordinated Universal Time, but I think the term was originally French, because apparently the French are really big on standards. So a lot of standards actually are derived from French, from the French version of the words. Okay, abbreviated UTC is the time standard. So basically it's a universal time, which used to be called Greenwich Mean Time. So basically, getting back to our time representation, yes, you can count the number of seconds since a particular date and use that to represent time. In that case, you don't have to separate the representation of date from the representation of time and combine both of those into one single big, huge integer. But the problem is, if I give you guys, your due date is this number of seconds since 1970, January 1st midnight, would you guys be able to figure out, when it's actually due? You can, but after a certain computations, right? So normally people don't use that representation, and normally people just use, the year, month, and day, as a normal representation. Okay, now let's think about. Okay, we don't have enough time to finish this example, but we can at least get it started just to understand why do we need to have our own types. Okay, let's just say we want to compare two particular dates. Okay, so let's not even compare. Let's just check whether two dates are exactly the same. Okay. What do you need to pass to this subroutine? Using only the constructs that we have learned so far. Don't you need to pass in 2 years, because you have the year from the first date and the year from the second date? So now we have bival, year 1, year 2. The year from the first date and the year from the second date. And then you need to pass in the same thing for the month 1, month 2, bival, day 1, and day 2, day in month. And the return is easy. Okay, that's not the key point of this demonstration here. The key point is year 1 has to equal to year 2, and month 1 has to equal to month 2, and day 1 has to equal to day 2. Right? If I want to write a subroutine to check whether 2 dates are equal, using only constructs that we have talked about today, this would be a reasonable way to do it. How many parameters do we have here? We got 6, right? And all of these are numbers. If I accidentally make a mistake and I pass the day of a particular date to the year, do you think the program would notice anything? No. So with 6 parameters, how many mistakes can I make?
36.
Lots of mistakes. Okay, because I can accidentally pass the year to the month, the month of the first date as the month of the second date, and so on and so forth. And nobody's going to tell me that there's a problem, because guess what? They are all numbers. They can all be compared. There's not a problem. Okay, as far as the subroutine is concerned, it cannot detect problems like that. Okay, so what is the root of this problem? Why can I make so many mistakes, for something this simple? Okay, let me give you an analogy before the end of the class, and then you guys will understand right away why we need records. Take any form that you have to fill in. Let's say a student registration form. Okay, when you register the first time, so they will ask you about your first name, your last name, your address, your phone number, your birth date, and so on and so forth. Instead of seeing that as one single piece of paper or as one single screen, when you do it online, think of each field as one screen or one little piece of paper. Okay? So your last name is one little slip of paper. Your first name is a little slip of paper. Your birth date is a little slip of paper, and so on. So what would your form actually look like, after you fill in the entire form? It will be a little stack of pieces of paper, right? Okay. So that means it's not convenient to begin with. Now, let's say that you have your own little pile of paper, and somebody else, has his or her own little pile of paper. You guys run into each other, and all the little slip of paper got spread out, and you have to pick up the pieces of paper. Can you easily tell which one is yours and which one is the other person's? Not really. Okay, because all you can see are little slips of paper with numbers and names and whatnot. Now, eventually, you guys can probably still figure out which one is which paper belongs to whom, but it will take some time. That's the world without records in programming. Okay, everything is a little bit of something. Okay, but you don't have a big structure to say that, oh, guess what? We have a normal form now. One piece of paper with different fields to fill in. Okay, you drop it, you have another person's, another person's application form to get mixed up with yours. It's no problem. As soon as you pick up this one is mine, the entire sheet, okay, everything that relates to you is on it. Okay, yep.
Where do you call them records?
Records or structures. Okay, they basically mean the same thing. It is also called a class in objects. No, they're not like objects. Okay, there's a slight difference. Okay, we'll explain that later. But I just want to explain the rationale behind having records or structures as one way to organize, to make up bigger things from little things. Okay, because sometimes we want to handle the big thing. Just think of making copies, right? Okay, let's make 5 copies of your form. If your form is on one single sheet of paper, it's easy. Just slide it onto the copier, press the button once, 5, press enter, you're done. If each field of your form is one little slip of paper, it's a very big hassle to make 5 copies.
So is it like saying records for month, from month from date and 1 to 31?
Basically, in order to represent a date, we will define our own aggregate type, which has 3 slots. The first slot is the year, the second slot is the month, the third slot is the day of month. Then we have now this new thing, every single date variable has 3 fields. And as a result, this particular subroutine only needs 2 parameters instead of 6. The chances of a mix-up is much lower than the way it is now. So we'll talk about that on Wednesday, and don't forget to work on your homework assignment so we can address any questions on Wednesday.
Have a good night.
Good night.